back at the runs that came out at 12Z on the 10th, then look at the 0Z June 11th runs, the 12Z June 11th runs, and then the event was supposed to occur during the afternoon and evening on the 11th. So just looking at a basic pattern of what we were looking at here, this is 300 millibar heights and wind, and you can see the country was dominated mostly by a large ridge at this time. The 12Z on the 11th, 300 millibar pattern is shown on the left, and then the 0Z, or actually the 21Z pattern on the 11th is shown on the right. And you can see Pennsylvania and New York was in northwest flow. There was a fairly strong jet streak that was forecast to be tracking southeast across southern Canada, with New York and Pennsylvania in the right exit region of that upper-level jet. So upper-level jet-wise, it didn't look like the pattern was very favorable for a lot of large-scale forcing for upward motion over New York and Pennsylvania. At 500 millibars, you can see again northwest flow. Fairly strong northwest flow across the area. Looks like 40 knots at Albany at 12Z on the 11th, and 60 knots at Buffalo at 12Z on the 11th. So northwest flow looks like the main shortwave aloft is well back to the northwest, just to the south of Hudson's Bay, north of Minnesota. There is, however, a weak shortwave that's passing over western New York at that time. And then by 0Z on the 12th, the weak shortwave that was over western New York has kind of tracked off the New England coast. The strong shortwave that was over to the southwest of Hudson Bay is kind of due south of Hudson Bay to the north of Lake Huron at that time. So it looks like western and central New York, if anything, are maybe in a very weak shortwave ridge between the two systems at 0Z on the 12th. At 850 millibars on the left, you can see the 12Z on the 11th pattern. The dashed red lines are temperatures. The solid black lines are heights, and the green shading is moisture. And you can see definitely at 850 there was a warm front moving across Pennsylvania and New York at 12Z on the 11th. You can see some pretty strong warm air advection implied over Pennsylvania and New York at that time, with it looks like at least 50 knots of flow from the west-southwest at 850 over upstate New York. By 0Z, now we're looking on the right side here. You can see there's a fair amount of moisture, but the strong warm advection has kind of mostly passed off to off the coast of New England, and the temperature advection pattern is kind of neutral over New York and Pennsylvania at this time. And then finally, looking at the surface, again at 12Z on the 11th, so in the morning on the 11th on the left, and then in the evening on the 11th on the right. And there is a cold front that's tracking through, it looks like, western and northern Michigan at 12Z on the 11th. And you can also see there's a warm front passing through central New York, extending down into central Pennsylvania at 12Z on the 11th. By 0Z on the 11th, or 0Z on the 12th, so now we're on to the right side again. The cold front looks like it's passed east of Lake Huron at that time, while the warm front looks like just moving into western New England at that time. So again, that kind of puts Pennsylvania and most of upstate New York kind of in a null zone between the cold front to the west and the warm front to the east, so kind of in a warm sector there. Look at just a little bit of water vapor imagery. Again, that's around 12Z on the 11th on the left, and then around 15Z on the 11th on the right. And you can see the associated with that mid-level shortwave tracking across southern Canada. You can see there's a dry surge coming in aloft. You can also see enhanced clouds moving eastward from New York into New England associated with the warm front. Again, with that surge of mid-level dry air coming in behind that initial warm front. Looking at the radar, so on the left we have 12Z on the 11th, and on the right we have around 15Z on the 11th. And this is basically the convection that was associated with the morning warm front as it passed across upstate New York toward New England. You can see there was a cluster of showers with some embedded thunder. This was all elevated convection, so there was no severe weather going on at this time. It was mostly just rain with some embedded thunder. No severe weather. And it was a fairly progressive system, and we've been pretty dry, so there was no flooding really concerns with this either. The concern for this day was later in the day behind this initial shot of this initial MCS associated with the warm convection. The models were showing the development of some at least moderate values of CAPE, along with a pretty moderately strong northwest flow aloft. Northwest flow aloft is often kind of a well-known pattern for possible severe weather in the Northeast, so that kind of had us on edge. And the NAM you can see on the left, this is a NAM forecast valid at 21Z on the 11th, so late in the afternoon on the 11th, valid at Binghamton in south central New York. And it's a buff kit sounding, so in the indices on the left side of the screen there, you can see there was a mixed layer CAPE forecast of 2,020 joules. So some moderate values there. On the right, you see the forecast from the RAP valid at the same time. And this is a pattern that we've seen comparing the RAP and the NAM for the last couple of years in our area, is that the RAP typically forecasts much, much less CAPE. And you can see why by looking at the lower part of the sounding. The RAP has a much deeper and a well-mixed boundary layer extending up above 800 millibars. The NAM's boundary layer does not extend up above 800 millibars. So as a result, the RAP is much drier, much less CAPE, only showing a value of about 673 joules per kilogram. Both models show quite a bit of dry air in the mid-levels, and that was a concern from the forecasters here, is that we would be in kind of a dry mid-level environment, possibly in between the two areas of best large-scale forcing. So we kind of thought that maybe this is a situation where it might be difficult to generate convection, but if convection did get going, we were going to have very strong wind fields and good deep layer shear. So the concern was, would we get the convection to actually get started? And if we did, we probably would be looking at some severe weather. So these are SPC's convective outlooks. The one on the left, I think, was issued during the day before the event, so during the day on the 10th, and there was a large widespread area of slight risk across New York and Pennsylvania. And again, I think they were keying on not so much the MCS that would be coming through in the morning, but convective redevelopment behind the MCS during the afternoon. The convective outlook on the right was issued on the midnight shift on the 11th, so early morning on the 11th, the day of the potential event. And you can see there's a slight risk. They cut back the slight risk a little bit across New York and Pennsylvania, but still you can see it covers a good chunk of the southeast half of New York and almost still the entire state of Pennsylvania except for the far southwest. So cutting back on it slightly, but still expecting some severe weather across the area later that day. And then right up to the onset of the event, this is the Meso-scale discussion that was issued at 18Z on the 11th. So the initial elevated MCS had gone through with some rain, but no severe weather. But you can see the SPC was still anticipating the potential for some damaging wind and hail kind of from Albany and east central New York down through, a good chunk of central Pennsylvania back toward Pittsburgh. So, even at 18Z, when we're kind of in a lull in what's going on at that time, stuff was expected to redevelop, and I think you'll see from some of the Hi Res models that I'm about to show, you can see why that was the expectation. So we'll back up now a little bit, and we'll look at some model runs from 12Z on the 10th, so the day before the event, and this is from the SPC's Storm Scale Ensemble of Opportunity. And you can see on the left there is the probabilities of greater than 40 dBZs reflectivity, and that's valid at 12Z on the 11th, so in the morning. So you can see the enhanced values going across New York and Pennsylvania. That was associated with the warm front. But then on the right, you can see the forecast valid at 21Z on the 11th, and you can see still enhanced reflectivity probabilities extending from southern New England back across southern New York and central Pennsylvania. So apparently there were several of the high-res models that make up this ensemble that were still predicting significant convection to be going on behind the warm front late in the afternoon on the 11th. And then here's the spaghetti reflectivity at that time, and you can see, the culprits here. The NAM 4-kilometer nest in particular had a large area of convection that was supposed to develop in central Pennsylvania. Several of the other models that are in this ensemble, you can see were also convecting and forecasting significant convection, highlighting the area from central Pennsylvania back across eastern New York, the Catskills, northern New Jersey, and actually all the way in across New England as well. Some other things that we like to look at from this storm scale ensemble of opportunity. Maximum of updraft helicity was being forecast across central Pennsylvania, and then that's on the left, and then on the right, an enhanced probability of wind speeds greater than 30 knots at 10 meters. Looking at the 4-kilometer CONUS, the NAM Nest 4-kilometer run for, again, this is the 12Z run for the day before the event. You can see kind of a broken area of showers with some convection at 12Z on the left, and then at 21Z, valid at 21Z on the right, you can see this area of discrete storms that were forecast to develop over central Pennsylvania. Given that strong deep layer shear that we were supposed to be in at that time, I think a forecaster could look at that and basically be on the outlook for possible supercells over central Pennsylvania at valid at 21Z on the 11th. And then here's some forecasts from the Hi Res Window runs. You can see they look much less impressive than the 4-kilometer NAM. On the left is the NMM core. On the right is the ARW core, 4-kilometer. This is from the Penn State E-Wall. And you can see really just forecasting just isolated convection over Pennsylvania and New York at 21Z on the 11th. Looked like the NMM maybe was forecasting a little bit more over the Poconos in northeast Pennsylvania, but neither model looked as impressive as the 4-kilometer NAM. So now we'll go ahead and we'll jump ahead to the 0Z runs on the 11th. So we're about 24 hours or a little bit less from when this event was supposed to occur. Again, on the left, you can see the reflectivity probabilities associated with the morning MCS. And then on the right, the reflectivity probabilities valid at 21Z. So this is the convection that we would have been concerned about, the afternoon convection that develops in the wake of the MCS. And again, high reflectivity shown from western New England across eastern New York and down through central Pennsylvania. And again, here's the spaghetti plots. And again, you can see lots of the high-res models that make up this ensemble were generating convection at the 21Z on the 11th. And again, this would have been the time that we would have been concerned, given the the moderate instability and pretty strong deep layer wind fields that we were expecting at that time. Updraft helicity was still bullseyeing on the left there. You can see bullseyeing over northeast Pennsylvania, but some enhanced probabilities covering New Jersey and a good part of Pennsylvania. And then again, the 10-meter winds a little bit to the south, covering maybe the southern half of Pennsylvania. And now what I have here is a comparison of the 0Z 4-kilometer NAM on the left and actually a later run from the HRRR on the right. And the key on here is, again, on the left, you can see the 4-kilometer NAM was showing still not the same pattern it showed before, but still discrete cells covering the area from the Catskills and southern New York back into central Pennsylvania. And again, given the moderate instability and strong deep layer wind fields that we were expecting at that time, discrete cells very possibly could have been supercells based on that forecast on the left. On the right, the HRRR didn't look quite as impressive. It was a little bit further south with its convection and maybe not quite as intense with its convection. Now we can look at actually a forecast from the experimental HRRR versus the NAM rapid refresh. These were, again, 0Z runs from the 11th, and they were valid in the morning on the 11th. So, again, this is the initial MCS coming through. the HRRRX on the left and the NAM rapid refresh on the right. See, they look fairly similar. The NAM rapid refresh may be a little more convective, but basically a blob of showers with some embedded convection coming through in the morning. And then by early afternoon, this is valid at 18Z on the 11th, you can see some pretty significant difference here. The HRRRX showing not a lot of development behind the initial MCS, one cell there in northwest of New York City, one cell just northeast of New York City, but not a lot going on. Whereas the NAM rapid refresh showed this, these very large convective clusters that looked kind of scary and organized back across the Finger Lakes and northern Pennsylvania at valid at 18Z on the 11th. So again, you take a look at that, and given the environment, you'd be concerned for southern New York and northern and central Pennsylvania for maybe a significant convective outbreak. Comparing the CAPE from the HRRRX and the rapid refresh NAM valid at 18Z on the 11th, you can see that the NAM rapid refresh, it looked like it had a little bit more CAPE across Pennsylvania at that time. A little bit hard to read, but it looks like there's probably some CAPE values in at least in excess of 2,500, if not 3,000 joules across parts of western Pennsylvania at that time. Whereas on the HRRRX, the experimental HRRR, the CAPEs were more like in the 1,000 to 2,000 joules per kilogram range. Also looking at some Hi Res Window NMM versus ARW runs that ran at 0Z on the 11th and were valid at 21Z. And again, the idea here looks like these Hi Res Window runs were not very bullish for New York or Pennsylvania. So that gave us some pause about, how much convection would develop in the wake of the MCS. Both runs just showing basically some isolated convection across Pennsylvania late in the afternoon on the 11th. So now we'll go to the most up-to-date runs, or the shortest range runs. These are the 12Z runs that were run on the 11th. So basically just like 6 to 10 hours prior to the onset of any event that would occur. And these are the reflectivity probabilities from the SSEO, and still showing some enhanced probabilities from southern New England back across central Pennsylvania and southwest Pennsylvania. And again, I only was able to get the zoomed out view here, unfortunately, but you can still see certainly from the spaghetti plot, several of the runs still were forecasting significant convection across central Pennsylvania up into southeast New York at that time. Again, this is valid 21Z on the 11th. There was still an area of enhanced updraft helicity in northeast Pennsylvania and covering a good deal of Pennsylvania at 21Z on the 11th, although it looks like the values were a little bit lower than they were on some earlier runs. It was backing off a little bit. Looking at the updraft strength on the right, it was still showing enhanced probabilities of significant updrafts from southeast New York back through central and southwest Pennsylvania. The actual bullseye now is being forecast back over southwest Pennsylvania, and it looked like maybe backed off a little bit from some of the previous runs, but still a signal there. So 12Z NAM, which remember was showing the discrete cells earlier, you can see the 4-kilometer NAM on the left, still showing some pretty good cells. Probably not as impressive looking as some of the previous runs, but still some pretty decent looking cells there over the Catskills and down into central Pennsylvania. By contrast to HRRR, the convection does not look as active, kind of in the same general area, but just not quite as active as the 4-kilometer NAM. And then the rapid refresh, the Hi Res Window runs. Actually, if anything, looked maybe a little bit more impressive than they'd looked before, kind of targeting southwest and south central Pennsylvania with some kind of active convection for later in the day. And then we can look at the comparison between the experimental HRRR and the NAM rapid refresh. And again, this is valid at 21Z. And the big thing to notice here, even the experimental HRRR showed some active convection in southwest Pennsylvania, but on the right you can see the NAM rapid refresh really showing the development of a significant convective system across south central Pennsylvania to the south of State College. Certainly, if that were something like that were to verify, given the environment that was expected, lots of severe thunderstorm warnings would likely be coming out of the State College office down along the Pennsylvania Turnpike, Harrisburg, and probably heading down toward Washington, Baltimore, and Philadelphia eventually. So that's the 9Z run on the 11th. And again, comparing the capes, not surprisingly, the NAM rapid refresh was more impressive with the convection, higher with the cape values. We can look at the 12Z comparison, and it looks like both models, especially the NAM rapid refresh on the right, seem to be backing off. Still showing some convection in south central Pennsylvania, but not nearly as much as it did before, whereas the HRRRX on the left was showing just really some spotty stuff in southwest Pennsylvania. Still quite a bit more cape on the NAM rapid refresh on the right versus the HRRRX on the left. Looks like some values are up around 4,000 joules per kilogram in southeast Pennsylvania on the NAM rapid refresh on the right. And then finally, now we're talking, less than 6 hours before the event. The HRRRX on the left showing some spotty stuff in southwest Pennsylvania. The NAM rapid refresh on the right, a little bit more coverage. Looks like a pretty significant cell up there in the Catskills. A significant cell to the northwest of New York City, one to the west of New York, near south of Allentown. And then a little bit hard to see, kind of on the edge of the domain there, but something fairly significant also down in extreme southern Pennsylvania. So again, the NAM rapid refresh, more impressed with convection for later in the day, based on the 15Z runs as well. And then again, the cape, more cape on the right there with the NAM rapid refresh as opposed to the HRRRX. What actually verified cape-wise, and of course I'm going to show the radar to show you what happened. Radar, that's the end of the presentation. What verified cape-wise, it looks like a large area of 1 to 2,000 joules. Little bullseye there near 2,000 joules in central Pennsylvania, but mostly it looks like a large area of 1 to 2,000. This is from the SPC meso-analysis valid at 21Z. And then looking at some actual soundings, you can see the NAM sounding, the NAM 4-kilometer sounding on the left versus the observed sounding on the right. On the left is Pittsburgh. The NAM 4 sounding is dashed. The observed is solid, and so you can see more moisture in the dashed sounding than in the solid sounding. So again, the NAM 4 may have been overdone with a low level moisture. That's for Pittsburgh. For Buffalo, the same kind of thing. Again, the dash sounding is moister at low levels than the observed sounding. And again, the dash sounding is the NAM 4 kilometer and the observed. So it looks like the NAM 4 was overdone with low-level moisture and, as a result, probably overdone with the cape. HRRR versus observations. Again, looks like a slight tendency for the HRRR to be slightly overdone with low-level moisture at both Pittsburgh and Buffalo, but it looks like not as much of a bias there as previously with the NAM. Again, I'll go back. There's the NAM comparisons with the observations, and there's the HRRR comparisons with the observations. So again, maybe a slight tendency for a little bit too much moisture in the boundary layer, but not as much as with the NAM. And then finally, this is the NAM 4 kilometer on the top versus the HRRR on the bottom at Latrobe, which was a sounding site just to the east of Pittsburgh, and you can see quite a difference in low-level moisture there between those two soundings. Again, with the NAM, that's the 4-kilometer NAM nest at the top, just much moisture, and as a result, more cape. And then finally, here's the radar. So what happened in the wake of this MCS as it moved off New England, the New England coast? And the final answer is not a whole heck of a lot. You can see even 21Z there on the right, just some spotty, isolated convection across southwest Pennsylvania, 1 or 2 non-severe cells in the Catskills northwest of New York City. I think what actually happened, I think in the Pittsburgh County warning area, there were a few isolated reports of some tree damage, but across central Pennsylvania, southern New York, New Jersey, really next to nothing. So this just kind of summarizes the way I saw this. It was a null event. High-resolution models indicated more convection than what actually happened. It looks like large-scale, bullet number 3 there I think is kind of interesting. Large-scale forcing for upward motion for this case looked like it was lacking, and we're wondering if this may be a bias with some of these high-res models. Seems like we've seen this before, too much convection in regimes with limited large-scale forcing. I'll just read down the bullets here. All the high-resolution models indicated some convection. Looked like the 4-kilometer NAM and the NAM rapid refresh were the most bullish, so they were probably the most wrong. Several of the models in the SSEO were definitely overdone. The NAM and the NAMRR looked like they were significantly over forecasting CAPE and low-level moisture. The best forecast may have been from the Hi Res Window WRFs. They never really showed much more than isolated convection. And again, only a few isolated cells were ultimately observed, mainly southwest Pennsylvania, with a few severe wind reports. And that is my presentation. I'll take any questions if anybody has them.